we talked about how different tables in MPLS are built, how the labels are exchanged, how we are building the label information base, how we are building the label forwarding information base, and so on. So now the time is to actually look at this in action. So to do that, I'm going to build a network that consists of R5, R4, R2, and R6. And they're going to be interconnected like this. And what I do have pre-configured here is that they are actually all running OSPF in area 0. Now, as I mentioned before, there is absolutely no prerequisite for MPLS to run OSPF. You can run any routing protocol that you like, but I personally prefer OSPF, so this is why I have this configured. So let me just briefly connect to all these devices. So here I have R5, R4, R2, and R6, just like I have on this diagram. So the goal here is to build the MPLS network. So now that I have OSPF actually configured and now that OSPF actually works, so if I do show IP route OSPF here, I will see that I actually have all the OSPF routes in place. And just as a brief test, I'm going to ping from R5 to R6. So there we go, here goes the ping, and this actually works. So I do have reachability from R5 to R6. I do have end-to-end IP reachability. And as I mentioned, this is one of the prerequisites of MPLS. Now, another thing that is prerequisite, so I'm just going to write this now because now we are talking about the practical aspects of MPLS, is and pardon my spelling, I'm not entirely sure that I spelled that correctly. So number one is that you do have fully converged or fully operational IP routing. So if you have fully operational IP routing, you are in a position that you can actually start building the MPLS network. If you don't have fully converged IP routing, don't even attempt to build your MPLS because you won't be able to actually do that. Now, number two prerequisite on IP routers is that you actually have IPsef enabled. If IPsef is not enabled, your MPLS will not work. And then third prerequisite is you to configure some sort of label exchange on interfaces. And here, this could be LDP, this could be TDP, and as I mentioned before, you could have RSVP, you could have BGP enabled, or you could be using static. Now, for the purposes of the CCI lab exam, you can assume that you will not be seeing these three. So RSVP, BGP, and static, very, very unlikely. And also, very, very unlikely that you will be seeing TDP. But if you see any one of these, this one might be very likely. Might be likelier than these. These are, I can almost guarantee you will not be seeing this. Now, for LDP, you can count on it. So if you do have MPLS in your network, you will actually have LDP to deal with. So these are the prerequisites. So one is that IPsef is enabled. Now, these are the basic prerequisites, but when you are configuring MPLS actually, this should be the steps for configuring MPLS. The first thing is IPsef, which is enabled by default, but is it enabled by default in your lab? You don't know that because you are starting with some pre-configuration. The other one is MPLS IP globally. Now, this is also on by default, but is it on by default in your labs? And 3, I would always set MPLS, LDP, router ID, and then you specify the interface. By default, the loopback with the highest IP address will be used, but then again, I'm not going to leave anything to the default. Now, highly recommended, not mandatory. So these are not mandatory. Highly recommended, but not mandatory, is to say MPLS label range. And then you specify the low end and then the high end of the labels. Now, I'll explain why this would make sense to do. and then finally interface X MPLS IP. So these would be the steps that I would always do when I configure the MPLS. So let's start in our network here. So I have R5, R4, R2, and R6 in the network. So let's start from R5. So I'm going to go here and I'm going to fire up my text editor. So I'm going to listen to my advice. So the first thing that I'm going to do is I'm going to say IPsef, and then globally I'm going to enable MPLS IP. But I'm going to wait with this command just a little bit. Now, the next thing that I said here that is in my step of things is I'm going to specify the MPLS router ID. So I'm going to say MPLS LDP router ID, and I'm going to use loopback 0. And then I'm going to have MPLS label range. Now, unless I'm restricted in the lab, I'm always going to use the labels that make some sense to me. Now, what labels make sense to me? Well, for example, on R5, it makes perfect sense to use labels from 500 to 599. On R4, from 400 to say 499. On R2, from 200 to 299. And on R6, from 600 to 699. Now, I have not been asked to do that, but imagine if I didn't do that. If I didn't do this, what would happen is R5 would have a label 17 assigned for something, R4 would have label 17 assigned for something, not necessarily the same thing. Same thing for R2 and same thing for R6. So when I see label 17 somewhere, I would have to think much harder, where does this label 17 actually come from? Is it coming from R5 or R4 or R2, or is this the correct label or is this the incorrect label? Now, mind you, it's not a problem if R5, R4, R2, and R6 all assign the label 17 for different things. It would still work perfectly. But for me, as the human operator, as someone who might need to troubleshoot this network, this may actually present a problem. So this is why I'm going to assign the labels that are immediately going to tell me from which router do these labels come from. So if I see label 600 to 699 somewhere, I know exactly where it's coming from. Now, with this approach here, that means that I can use only 100 labels per device. If you are worried about this, well, just add one more number here. So assign from 5,000 to 5,999, or, something along those lines. So, but assign some label ranges that make sense to you. Now, the problem with this approach is that if you already have an active MPLS LDP session anywhere on the router, LDP or TDP, or if labels are used in any way, this command here will actually have no effect. So, to make it actually have effect, we are going to turn the MPLS off, and then I'm going to turn it back on. So this is why I was holding off with this command a little bit, because at this point here I want to turn off the MPLS, I'm going to change the label range, and then I'm going to turn on the MPLS back on. So at this point here, what is my next step after I have defined the label range? I'm going to go into the interface. So on my R5, let's take a look at that interface. It's going to be interface serial 010504, and I'm going to say MPLS IP. So this is going to be the configuration on R5. So let's go to R5 and paste this in. So when I paste this in, right now I have actually turned on MPLS functionality. And if I do, for example, show MPLS LDP bindings, I will see that my lib table got generated. So this behind me is now my label information base. Now, this label information base here shows me that I have, for all of my routes that I have in a routing table, I have actually assigned the local bindings. And I can see here that, for example, the loopback of R2, the label 500 was assigned, for loopback of R4, 501, 502, 503, 504, and so on. But this is the interesting one. So for the label, for the route of 192.168.0.5, for my own loopback interface, I can see that I have actually assigned an implicit null label. The same thing for the interface 45, the link between 4 and 5, because this is directly connected route on my side, I have actually assigned an implicit null label. So this is what I'm going to get when I enable MPLS on an interface. Now, on R4, I have not yet done it. So on R4, if I run the same command, MPLS LDP bindings, this is what I will get, that lib is not enabled. Now, mind you, if I do show run include MPLS here on R4, I don't see that MPLS is enabled globally. If I go to R5, show run include MPLS, here in the global configuration, I also don't have that command. This is from a sub-interface. You can see that because it's indented by 1, which means that MPLS command, the one that I ran, is actually the default. But you can see here that on R4, the table does not exist. It doesn't exist because there is no need for it. And this is what I mentioned earlier when I said that all sorts of things are going to happen in the background the moment you enable MPLS on one of the interfaces. And this is precisely what I've done here. What I've done, when I enabled this on an interface, the table in the background got created. Another table that got created is, of course, the MPLS forwarding table, or the LFIB. And I can see that if I do show MPLS forwarding table, now this is the forwarding I have. Now, this is significant here because I'm told that for all destinations, I'm using no labels. Well, I'm using no labels because I don't have any remotely assigned labels, but the table is there, it's ready to go. If I run the same command on R4, show MPLS forwarding table, I will see here that no MPLS applications are enabled, or MPLS is not enabled on any interfaces. So again, this table doesn't exist on R4. So the creation, the act of me actually enabling this on an interface, this was the command that actually triggered the creation of the labels. Now, this is how the labels got created on R5. But there is one more thing, one very, very practical thing that I want to show you. I have enabled LDP now on an interface, and I can see that if I do show MPLS interfaces, I can see that on interface serial 010504, I have MPLS enabled, that LDP is enabled. There is no tunneling in use, the BGP is not used, the static labels are not in use, but it is operational because I have LDP enabled. So these are different methods that you can use to enable MPLS on the interface, but this is not something that you need to be concerned about. This is what we care about. So we have enabled LDP, and MPLS is, as far as this router concerned, is operational on the interface. So let's take a look at LDP. One of the most useful LDP commands that you can run is show MPLS LDP discovery. So if you do show MPLS LDP discovery, what we are going to see here is, first of all, what is our local LDP identifier. We will see that this is our loopback interface followed by :0. You will always see :0 unless you are running MPLS in something that is called MPLS cell mode, and that would require a specially configured ATM interfaces, which is not something that you will ever see in your life. So, discovery sources tells me on which interfaces the LDP is actually enabled. And here I can see that LDP is enabled on serial 010.504, that LDP is enabled, this could be LDP, TDP, or both, and I see that I'm transmitting the hellos. Now, this output here behind me is how things look when they don't work. So this is the output that I'm going to be seeing if I'm troubleshooting MPLS. This is how a broken relationship between two routers will look. Why is this broken? Well, because we are transmitting the hellos, but we are not actually receiving any hellos. We are not receiving hellos, of course, because R4 is not actually configured for MPLS. So let's configure R4 for MPLS. So going to my text editor here, very few things are going to change. I'm going to change the label range and simply change the interface that is in use here, and I have 402 and 405. So I'm going to go to R4, going to paste this in, and still looking at R5, now I'm getting this log message. Now, this log message here means that the LDP neighbor 192.168.0.4 came up. Now, let's rerun our show MPLS LDP discovery. This is how the output looks when it probably does work. Now, why do I say probably? Because there are still things that can be broken, but now we see that on this interface we are running LDP, we are transmitting hellos and we are actually receiving hellos. And we can see that we are seeing the neighbor 192.168.0.4:0. This is what shows me the discovery operation. This is the UDP based operation. But what about that TCP session? Well, based on this log message here, I know that this session is up because this log message will show up when the session gets established. But let's actually take a look at the session. And to do that, I can run show MPLS LDP neighbor command. And here I see that I have the peers identifier 192.168.0.4:0. This is my local identifier, and this is the actual TCP session. And I can see that it was actually established by 192.168.0.5. So R5 was the one that established the session. It will always be the higher number. From the random port number to 192.168.0.4 port 646. Now, this command here is the command that you should almost never run. So I'm going to delete this output. You should get in the habit of running show MPLS LDP neighbor detail. Now, as you will see, the output between detail and non-detail is remarkably similar. But one thing that the detail will show you that this command will not is the configuration for the authentication. You will also see it on this line if it was enabled. There will be an indication here that MD5 is on. Now, if you don't run the detail command, you will not have information whether the authentication for LDP is actually configured or not. Since it's mentioned in the blueprint, I'm going to configure authentication between R4 and R5. It's going to be a very simple configuration, and that is done on the MPLS LDP neighbor command. So on R5, MPLS LDP neighbor 192.168.0.4, and remember, you actually have to use the loopback address here, whatever the LDP identifier is. So I need this thing here without :0, and I'm going to specify the password. So when I configure this now, let's take a look at the output of show MPLS LDP neighbor detail. Take a look at this. It says password is not required. And in the version of iOS that you will have in the lab, this will always be the case, because password is optional unless you run the command MPLS LDP password required. But this is not possible to do in the version of iOS that you will have in the lab. My version here is slightly newer, so I'm running 12.4.24t, and in the lab you will have 12.4.15t. So you will always have this not required, but don't worry about it, it will still work. I can see here that the password was actually configured on the neighbor statement, but that my current session, in comparison to the configuration that I have, is actually stale. It still works, but that means that whatever I have configured now is newer than what it was there when the session was established. So when I configure the password on only one side, this is not actually going to take the session down. Now, if I actually clear the session, which you can do with clear MPLS LDP neighbor star or neighbor and then the address, now when the session goes down, now when it tries to reestablish, now I will be actually getting the error message that the TCP authentication is not operating. So that I have this TCP bad auth and that I'm not getting MD5 digest from R4. So let's fix that. So on R4, I'm going to say MPLS LDP neighbor 192.168.0.5 password IPExpert. So when I do that, I should be seeing the log message here that the neighbor is coming up, and here is the log message. And let me show you now how the show MPLS LDP neighbor detail looks. Now, this is the line here, and this is what I'm looking for. MD5 on. If you have this, your authentication is good. Also, if you take a look at this line, the password still says not required. It's configured on the neighbor, but now we can see that actually it is in use. Now, if you run just show MPLS LDP neighbor, you are not going to see any mention of the authentication. So you cannot tell whether this works or doesn't. So my recommendation is get into habit of using show MPLS LDP neighbor detail, because that will actually show you the authentication configuration that you have on your LDP. the question here is, do I recommend using show MPLS LDP neighbor detail over show MPLS LDP discovery? Well, no, that's not what I was saying. Because the command, remember how LDP operates. We have two routers, they have the connection, and then we have UDP hello, and we have TCP session between them. Now, if you want to see if this works, you are going to be using show MPLS LDP discovery. And if you want to see if this works, you are going to be using show MPLS LDP neighbor detail. So what I recommend is that you use this command instead of just show MPLS LDP neighbor. But I highly recommend that you actually use both always. Because remember, LDP has these two operations. It has the discovery process, who are the neighbors, and then it has the session. Now, when something's broken with LDP, you have to figure out which part is broken. Is it the session that is broken, or is it that we don't know the neighbors? Because if you see the neighbors and the session is not establishing, this is what you need to troubleshoot. But if you are not seeing the neighbors at all, you don't have to troubleshoot the TCP session. Why can't the neighbors see each other? Why doesn't the discovery work? It may not be something to do with the session. Maybe the session will work when you fix the discovery. So it's two separated processes, one that works with one, the other one that works with the other. Carrying on with this configuration, so now we actually have LDP configured between these two routers. Let's now proceed and configure it on R2 and R6. And these are going to be just very, very simple configurations. I'm not going to do any authentication or anything of the sort, so just very, very straightforward. So on R2, going to change the label range though. So this goes to R2. And again, I'm just going to wait for that confirmation that I do have this LDP neighbor coming up. I'm going to wait for it here. And on R4, now I'm going to say show MPLS LDP discovery. There I have it. And on R2, show MPLS LDP discovery. I have it. Neighbor detail. I do have the neighbor. So it's okay to check just from one side in this case. So on R6, let's build this. And then 602 is what I need, so let's add this. I have the message, which means that the session came up, so, but anyways, I'm going to confirm show MPLS LDP discovery, and if I do show MPLS LDP neighbor, I can see here that I do have two discovery sources, but let me do what I was recommending you do, so discovery and neighbor detail. So here I can see that I'm running LDP on two interfaces, transmitting, receiving, and I'm seeing two peering sessions from R2, which means that it's pretty much all good. So how can I verify that this MPLS now actually works? Well, as it turns out, there is a very, very simple way of doing that. So I'm going to go to R5, and I'm simply going to say traceroute 192.168.0.6 source loopback 0. Now, when you do a traceroute in an MPLS network on Cisco routers, what is going to happen there is that when a traceroute packet is sent, so it goes from R5 to R4. So it goes from R5 to R4. On R4, due to the nature of traceroutes, we have sent it with TTL1. The TTL expires, and there is a code in iOS that is actually going to put the value of the labels on a discarded packet that were used, and they're going to be sent as the ICMP unreachable. So the ICMP unreachable that goes back from R4 to R5 is going to carry the information about which labels were used to send this traffic. This is why in the traceroute output, when we are doing the traceroute from the routers, we are actually going to see the label stack. So we can see here that it was label 402, which had experimental bits 0, which is very, very good troubleshooting tool, because now we can tell that from R5 to R4, the traffic was sent using label 402, which we know for a fact now was assigned by R4. How do we know that for a fact? because it is in the range between 400 and 499. Then we can see that R4 sent the packet to R2 with label 202, which again we know for a fact was the label assigned by R2 because that's what we configured. And then we can see that between routers 2 and 6 there was no label in use. So we can actually see that there was PHP action going on. So this is the easiest way to actually see MPLS in action. But this is not the magic bullet, because there could have been a thing configured that would prevent you from actually seeing the traceroute. So now this is the output that I'm going to get. Now it appears that R5 and R6 are directly connected. With this one thing, with this one simple command, I have hidden the MPLS backbone from it. What? Let me explain. So when we send a regular IP packet, right, one of the things that IP packet has, one of the fields, is the TTL. So this is the IP packet. Now, when we arrive with our label here, you may remember that one of the fields in the MPLS packet is the actual TTL value. By default, if you don't do anything on Cisco routers, the value of the payload's TTL will actually be inserted here. So if this was 1, the 1 will be copied here. That means that for MPLS packet, what's going to happen is this packet, when it was sent, here will have actual TTL 1. Now, if I do this command no MPLS IP, and I have several options, and the options that I can configure here are the one that I used, local. It can be forwarded or it can be both. Or if you just press enter, it applies to both. So I have 3 options here: forwarded, local, and CR. Now, for forwarded, applies to routed traffic, or I should say to transit traffic. So the traffic that is not originating or terminating on the local router. And local traffic applies to locally generated traffic. And if I just press enter, it applies to both above. What I'm going to be doing, so when you configure this, when we have an IP packet here that has the TTL value, instead of actually copying value to the MPLS, the TTL value of MPLS here is going to be set to maximum. So what's happening here is that even though I have done the traceroute, so when I do the traceroute here, what's happening is that the packet that gets generated is still an MPLS packet, but instead of expiring on R4, it is actually going to go all the way to R6. Well, actually not all the way to R6. It's going to hit R2, then R2 is going to pop the label, and what's left is an IP packet with TTL1, which gets sent normally to R6, and I get ICMP unreachable. So basically, from the traceroute output, I have hidden the MPLS backbone. Now, the reason why I'm telling you this is that in the lab, they can tell you, build this MPLS backbone and make sure that when customers are tracing through this network, that they don't see the backbone devices in your MPLS network. This is what no MPLS IP propagate TTL does. But remember these 2 options here, because for example, what is most commonly configured in service provider networks is actually this forwarded thing. Why? Because this would hide the MPLS network from the customers. But you, as the network operator, you can still trace route through the network, because if you are running this from a local device, this will be a locally generated traffic which won't be affected by this. So let's hide the backbone from the customer, but let's see it visible for us. So I'm going to say something like this. So if I do show run include MPLS. This is what I have now configured. So if I do a trace route, because this is locally generated traffic, this has no effect on me right now. But if I had a router that was behind R5, some device behind R5, that was doing the trace route across this network, it would actually appear as if R5 was directly connected to R6. We would have hidden R2 and R4 from the output of the trace route. So that's one more thing that I wanted to show you. But let's take a look at this same thing. So this was the trace route, and this is how the labels look. But now let's look into those databases and see how those databases actually see this traffic. So on R5, let's take a look at what the routing table tells us. The routing table here tells us that if I want to reach 192.168.0.6, I can reach it through R4 out of this interface here. Very good. So if I take a look at my label information base, so show MPLS LDP bindings, let's say 192.168.0.6/32. This is what I'm going to have. So I have the local binding, this is what I expected. I can see the label 502, that is the locally assigned label. And this is the remote binding. Now, the remote binding from 192.168.0.4 says this is label 402. So this is what I have in my lib. Now, if I take a look at my LFIB, if I do show MPLS forwarding table, this is what I will be seeing there. It says local label 502. If I receive traffic with this local label, replace it with this and send it out of this interface here. This is what I was telling you earlier, that, and it was this diagram here, that these two entries here, so these are the two entries that I'm talking about now, that in the iOS, they are actually going to show up as a single entry. But it's better thinking of them as separate entries, because what is happening here is if we receive the labeled packet, 502, we don't care about which network it was assigned to, which FEC or the forwarding equivalency class it was assigned to, because the only thing that matters was that it was a labeled packet. Now, but if we receive the IP packet for this network, it doesn't matter what the local label is. The only thing that we care about is the outgoing label and the outgoing interface. So even though here in the iOS, this is actually shown on a single line, it's better thinking of these two logically as separate entries that point in the same direction. So one for labeled packets and one for unlabeled packets. But in any case, if we want to send traffic for this network destination, we are going to be using this label, and we'll be sending it out of this interface, which is point-to-point next hop. We don't actually care about the layer 2 resolution in this case. We can also see this in Ceph. So if I do show IP Ceph, if I do show IP Ceph 192.168.0.6, of course now I believe that I have to do it like this. Yep. I'm going to see that next hop is 192.168.45.4, which leads me back to this bind here. So this is what tells me that this is the next hop. Out of serial 010504, and we can see the label there as well. So we can see that in the Ceph table, we can actually see pretty much the same information that we have here. Now, let's take a look at R4. So R4 is now receiving a labeled packet 402. Let's go there. So here, if I do show MPLS forwarding table, I will see that incoming packet 402 means send this traffic out of this interface here. If I do show IP Ceph, so I'm going to run show IP Ceph. Here, let me see if I can actually see. Oh, there is no show MPLS Ceph, so we have to be content with show MPLS forwarding table. So we can see here that incoming label 402 means send the traffic using label 202 out of this interface. And we can actually see that some traffic was actually sent there. Let's take a look at R2. Show MPLS forwarding table. We can see that 202 is now replaced with POP label. Now, it's important here to remember, if you recall, when we ran the same command on R5 at the very beginning, just when we enabled MPLS, all of these items here said no label. When you see no label here, this is MPLS delete operation. pop label means just that, pop the label. So on R2 here, we see that for incoming label 202, we are supposed to pop the label. Let's take a look at the lib on R2. If I do show MPLS LDP bindings, 192.168.0.6, this is what I have in my label information base. Local binding, this is what I expect. Now, this is the weird binding. This is the one that is pointless. This is the binding from R4. So we don't need this because the traffic for 192.168.0.6 is not behind here. But remember, liberal retention. So this is going to stay in the lib. But here we do have the remote binding that we are actually using. This is the one from R6 and tells us use the implicit null. So here in the lib we are told to use the implicit null, but here in the actual forwarding table it says pop the label. And if I take a look at the Ceph here, I will see that in the Ceph table there is not even a mention of the label. Because remember, in the forwarding table there is no implicit null label. That simply means don't send the label. So the implicit null will be there in the control plane table, in the lib table, but not in the forwarding table, because here we are not dealing with the labels. And finally, on R6, if I take a look at show MPLS forwarding table, MPLS forwarding table, I will see that there is no mention of 192.168.0.6. And this is what I mentioned, if you remember, on this picture when I said that on this ultimate hop, there will be no forwarding, label forwarding information base for the destination for which you are sending the regular IP traffic, which is what we need here, because R6's loopback is our own local interface. We are on R6, this is our local interface, or is directly connected route, or is behind the interface where we can send only IP traffic. And in that case, we are not going to have a label assigned for it. Or we're not going to have the label installed in the forwarding information base, in label for forwarding information base in the LFIB, because there will be no LFIB entry for that route. There is no need for it because this is just a regular IP traffic. MPLS is not IP. The things and tricks that might work in IP world may not work in MPLS. Do not use IP troubleshooting tools to troubleshoot MPLS. So, IP troubleshooting tools are ping, traceroute, show IP route. Now, those are useful commands, but in MPLS environment, and especially in MPLS VPN environment, some of these might be lying to you. You've seen the example of the traceroute just before, when we have hidden the MPLS backbone from your view. Now, imagine if you use traceroute to troubleshoot MPLS environment and that was the output you got. Where is the problem? Also, keep in mind that when you're using traceroute to troubleshoot the problem, the end node that is actually sending you ICMP unreachable needs to have the route back to you. If that node doesn't have the route back to you, can it actually send the ICMP unreachable? It cannot. So in which direction is the problem? Is the problem in this direction or in this direction? Is that node even supposed to have the route back to you? Is it using the correct interface to send back the unreachable? When you are troubleshooting MPLS, you need to use the MPLS tools. Now, what are the MPLS tools? Well, ping is a relatively good tool. You need to look into the MPLS databases. Remember, you have the control plane and you have the data plane. You need to troubleshoot them separately. Is your control plane okay? Are you having your LDP neighbors? Are you having your routing protocols operational? Do you have the databases set up? Do they exist? Is the Ceph enabled? Is MPLS enabled globally? Is MPLS enabled on the interfaces? Are you seeing MPLS discovery? Are you seeing MPLS neighbors? Are you getting correct information in your lib and your rib? Right? Are you getting the routes in the routing table? Are you getting routes in the label information base? Now, once you are satisfied that your control plane operates properly, you may want to go and take a look into your data plane. Now, in your data plane, you are looking, What are the labels in use? And remember, this is rule number 1 when you're troubleshooting MPLS data plane. Follow the labels. Immediately at the ingress point, where you are sending the traffic, where it needs to turn into MPLS traffic, from IP traffic to MPLS traffic, this is where you need to look at the labels. What is the label that I'm using? Is this the label that I'm supposed to use? Go to the next hop, follow the labels. This incoming label, where does it go? Follow the label, follow the label, follow the label, follow the label. This is a key for troubleshooting MPLS, is follow the label. Now, everything else is just the things that I've shown you. The commands that I've shown you, show MPLS LDP discovery, show MPLS LDP neighbor, show MPLS forwarding table, show MPLS LDP bindings. These are the commands that you need to run in order to actually troubleshoot MPLS successfully. But the key is to know not to use the IP tools. The key is to know how to use the MPLS tools. And there, follow the label is the best advice I can give you. Now, for the CCI lab, it's important to know that MPLS is probably not going to be a huge thing. But if you have MPLS, it's probably going to be sitting right there in the core of your network. And this could be this could be the case in the troubleshooting section. This could be the case in the configuration section. This means that it's not going to be a big number of points, but if you don't get it right, there could be so many things that depend on it. This is for the configuration section. In the troubleshooting section, well, I mean, worst case scenario is that one, or if you are really, really terribly unlucky, 2 tickets maybe depend on it. But it could be that you have more than 1 ticket that deals with MPLS. So it's very, very important to know how to troubleshoot it. So when you are troubleshooting MPLS infrastructure, this is it. This is what you have to do. Follow the label.